Good morning, everyone, and thank you for coming to our webinar here for Campus Wi-Fi, Myth versus Fact for IntegraONE and our partner in Campus Wi-Fi, Ruckus. Today, we're going to be presenting some slides and some focused material on Campus Wi-Fi with Ruckus and our partnership with Ruckus at IntegraONE. So a little bit, start off with some words about IntegraONE, 28 years and 48 team members and growing. We just had a acquisition that's not on this slide that expands our offices to include an office in Kingston, Pennsylvania, which is in the Wilkes-Barre area, with a great team of people coming on, highly focused in network engineering and security, including wired and wireless services. Who we are, besides what we do in the wireless arena, we have a compilation of services in various different sectors within technology, including security, data center, unified communications. Also on the compute side with storage, cloud services, and server and virtualization infrastructure, including hyper-converged. We have wide variety of markets that we represent, specifically today talking about campus Wi-Fi in the high ed and K-12 arenas, but also commercial, government, healthcare, and finance. Ongoing service approach. So again, we're not looking to come in and throw some equipment in your data center, turn it on, and configure it and walk away. We really want to be with you through the entire life cycle of the project, scoping out your use case, your business plans, and allowing you to grow with us as technology evolves, as your demands and needs evolve, that we can be there in response to help you make sure you have the best possible experience for your community within your wireless and wired networks. Some of our partners. And campus Wi-Fi, myth versus fact. So a lot of what we're seeing from our engagements is involved around continued capacity for growth, continued capacity for moving and migrating to wireless from wired where traditionally have been wired. A lot of concerns we hear about the number of devices and connectivity sitting within residential networks and dorms. We all know that, everybody has multiple wireless devices on them or around them at any one point in time. Obviously, that presents some challenges in providing good quality wireless at a high speed and high capacity. Along with that, when we extend outside into common areas, how do we light up common areas where, again, that capacity could be 1 or 2 devices 1 minute and 50 or 60 devices the next, particularly as events gear up in campuses and campus areas. Then boiling down to, wow, what are we doing to address, increasing need for areas within the scholastic and educational side of a campus, or where business is being done within a campus, as in labs, classrooms, research and development areas, libraries, common areas where there might be actual scholastic delivery or curriculum delivery or business delivery at a high volume over wireless, where it may have traditionally been more wired structure. So today we have MJ from Ruckus, Eris, with us to walk us through the slides and focus on the wireless technology that Ruckus brings to our solution set. And so I will turn it over to MJ to start our presentation and go back and forth a little bit with what IntegraONE brings and what our partner and Ruckus helps us augment in the wired and wireless structure. MJ?
Great. Thanks, Brad. Glad to be here with you. And thank you for all joining. If you have any questions, just stick them in the chat box. So we'll try and address them. If we can't answer them today, you'll end up with the answer sent to you along with the presentation, the recording of this presentation. So if you go to the next slide. I'm not sure why. There we go. So just to tee off, to pick off what Brad was talking about. So, the average number of devices. So I'm here this morning. I've got, 4 on me. How many do you have, Brad?
I think I'm sitting, including Bluetooth devices and things of that nature, I think I'm sitting about 6.
There you go. So from a traditional, where we've all been, so we were wired, so we kind of knew what that was. You take a computer, you plug it into a port or an Ethernet switch, and you kind of knew exactly what the capacity is that you were designing for. On the Wi-Fi side, that's a very variable number. As you just mentioned, we walk in with 6 or 7 devices. They all want to be connected. Depending on what the environment is, where I am on that particular physical building location, if I'm in a common space, there might be, or a cafeteria, there might be 1,000 devices sitting there, not all active at the same time, but they're there. And so most people think there's only 3. So, the reality is that most college students bring 7 devices with them, including phones, iPads, Galaxy Tabs, or some sort of console boxes, anything like that. And so definitely this is a challenge that most of us haven't anticipated, need to anticipate now. So go to the next slide. The more devices there are, the more their interference there is. For the longest time, we thought Bluetooth was going to kill Wi-Fi. We were running around, I know I was running around 8 years ago saying Bluetooth was going to be the end of Wi-Fi because it was operating in the same 2.4 gigahertz band that our 802.11g was back in those days. Bluetooth Low Energy has sort of helped us with that, and it's a very narrow band interference. But the more we propagate those kinds of sources of interference, the more we impact the performance of our Wi-Fi network. So there are those interference issues, capacity issues, just the fact that if I'm establishing a network and I don't have enough capacity in a room, every single one of us said, I think every one of us would agree that a bad Wi-Fi is better than no Wi-Fi, because if there was poor Wi-Fi, I would hop on our cellular networks and just work that way. But, many of us have got capped data packages, and so we want to save those precious, expensive data packages on our cell phones. We want to hop on local Wi-Fi. And if it's not working really well, it gets really frustrating. So you need to make sure that this escalated capacity, is being accounted for in our designs. Let's go to our next slide.
So, when we look at Ruckus and our wireless engineers, there's certainly we can come in and discuss and talk about, what your campus looks like. What are your, current deployments in the network costing you? How do you manage your critical applications and your demand and growth? Those types of things. So it's certainly something we bring to the table from a consulting perspective and our viewpoint across multiple of our customers and, again, multiple of our partners. Again, with this focus being on Ruckus, we can help you take a look at that and develop plans to meet those growth needs.
So one of the natural thoughts, so if I've got a room, with 1,000 people in it, so I just put more Wi-Fi in there. And that's sort of the natural thought to do something like that. And I run into it all the time. I've actually come to situations where I've got a school, for example, and they deployed a network maybe 6, 7, 8 years ago. And at the time, the technology was such that they put an access point in every single classroom. And you meet them now, and so those were old, G network, G or N networks, mostly G. And now they're looking at Wave 2, 802.11ac access points, and they want to go through and put an access point in every single classroom. And then they do that, sort of against your advice and counsel, and then they come and call you and say, well, it's not working the way we thought it would work. And the truth be told is that just more APs doesn't mean better Wi-Fi. So if we go to the next slide. This is actually a slide out of a Ekahau presentation. And in order, the life cycle of a Wi-Fi network, you have to plan where you're going to put those access points. So you're going to plan, you're going to validate it, you're going to troubleshoot it, you're going to monitor it. And it's an iterative process. So as you start out this process, you say, okay, well, I've got this building, and you need to do some analysis in that building, and it might be a theoretical prediction. A theoretical prediction is use a tool, could be Ekahau, could be products by other vendors, and Integra can actually help you with that. And you figure out where theoretically I should put these access points based on the way the building's laid out, the dimensions of the building, the materials of the walls. And then you go through and you physically test it. You actually say, well, I'm going to take a couple of access points and see, is my theoretical prediction close to my real prediction, close to what my theoretical one is? And you go through it. There's a pre-deployment site survey. You install it. Once you've installed it, you go through and validate it. So I've got this theoretical prediction I did, RF prediction. I installed the network the way it theoretically should be deployed. Now I check the physical thing. I look at spectrum analysis. Interference. Often I run into situations with customers, they say, well, this part of the room, part of the campus, Wi-Fi performance is really poor. They stuck an extra access point there, only to discover that it didn't really solve the problem. And they later discovered that, oh, there's some interference, narrowband interference of some kind, and you have to find out what that is. There was one customer actually had a server room, and they had an APC UPS that was generating because it had these inductors to go from DC voltage, 48 volts, up to 110. They used this thing called an inverter, and it generated all this interference. So all of a sudden, every day when they tested that UPS, everybody fell off the network at that time of day, and it was a source of interference. You have to actually go look, and there are tools to do that, and these tools actually Integra has access to these tools too.
Yeah, so I mean, we want to begin each engagement, whether we're novating an existing infrastructure or we're greenfielding a building or an entire campus. In some cases, it doesn't too much happen unless it's a brand new campus. Pretty much everybody's got some level of wireless deployed today. But we want to take a look at the layout of that, the physical layout, what the materials used in building the buildings are, you know, the floor layout, what is already existing in the air that we need to mitigate, and how do we place those APs? Because we don't want to just guess. We don't want to take a map of a campus and throw an AP there and draw a radius around it and say, yeah, that's it. So we're going to come out there with you know, tools that we mentioned in the previous slide. We're going to take a look at the airspace. We're going to analyze where your floor and ceiling are in that airspace and develop how much is there and available to you for utilization in a given area, how much interference there is, and what the expected performance should be. And then if we need to help mitigate some of that, or you know, augment what you have with different types of antennas, you know, we know that up front. And then, as MJ said, it's a matter of, well, that tool's not golden. It's not the be all end all. It's not a silver bullet to creating your plan. We also have to do some test placements and make sure that we are seeing the results we expect from our tools.
Another thing that sort of concern sometimes, you know, customers have said, well, you know, I've got legacy devices, they're old, and, you know, they're previous generation technology edge client devices. Why should I deploy the new technology now? So Wave 2, so 8211AC, just a little bit of background. So 8211AC sort of came out in two iterations. The first was Wave 1, and the second iteration was Wave 2. And Wave 1 or Wave 2, that's really a marketing term. But included in some of those iterations, those chipset generations, were additional features. For example, along with Wave 2 was this whole concept of multi-user MIMO, multiple in, multiple out, which would help improve performance of multicast traffic on a network. So the reason for actually doing something about that, by actually deploying current technology when you're actually refreshing your network, is because it takes you time to do that. Two, you are on a budget cycle. So not everybody can spend money whenever they want to. I know I can't. I have a fixed budget at home. I know, just for me personally, and enterprises and organizations have the same thing. They've got budget cycles. Every 2 or 3 years or 5 years or whatever it is, you know, it might be a write-off cycle when they've acquired product and they have to write it off the books before they can replace it. So you use the current technology at the time. And so today it's wave 2, and you're preparing your field, as it were. If you're a farmer, you're getting the field ready to plant seed and grow crops. You're actually preparing your infrastructure for future products, future clients. And one of those things are new cellular technologies that are coming in. So, and those are driven by the edge devices, but you actually have to have the infrastructure available to support it. So some of the things we're doing, just to give you an idea. So this is all part of wave 2. It's kind of a busy slide, but so transmit beamforming was the thing that came in with wave 2 technology, 8211 AC, and it's coupled with a thing called BeamFlex. And I actually talk about BeamFlex a little bit later. It's a technology we've had in our access points for quite a while, and you'll have a lot more insight on what that really means in a couple of seconds. Adaptive sounding, it's having the ability to do round loop control and testing of what the signal is that's going to a client and getting some feedback from the client. Network capacity utilization, so understanding how this Wi-Fi network is working. So analytics is a huge topic these days. We sometimes we call it big data. And depending on how big your network, the data gets kind of large. But having understanding how the network is performing, understanding what the drops are, understanding what the average throughput per client, how many clients I've got. Are clients having trouble roaming, moving around the infrastructure? That's all part of built into the new wave of access points that we've been delivering and the controllers that actually manage and control them. Per packet adaptive power. It's this concept that the cellular vendors have been doing for a long time. If I'm sitting 3 feet from an access point, because it's right above my head, should the access point talk to me at 100 milliwatts when it's not necessary? And why would I care about that? Because every time, it's a time slice technology. Access point, unless it's using multi-user MIMO for multicast traffic, each conversation is really destined for a particular client because it's got a MAC address built into it. So every time I talk to a client that's on the, to the east of the access point, that signal is seen by clients that are all the way around the circle and that traffic's not actually destined for those clients. So it's interfering with those clients, shall we say. So being able to actually adapt the power per conversation is a huge improvement in performance. Along with that, adaptive Wi-Fi cell sizes. So, that's a thing that a lot of vendors have been doing. We've been doing it also. So being able to heal the network. Part of that site survey we were talking about before, one of the criteria is, well, at any point in the infrastructure, how many access points do I want to be able to see? So the tools will say, okay, I want to be able to see 2 access points at all times. So what happens if one of those access points fails? Then if they've got a fixed power, so I decided, so the maximum power that a transmitter that is 100 milliwatts, say, but if I make my design that the access point's working at 60 milliwatts, then I'll in theory, need a couple more access points, but then my network can heal if an access point drops off because the other access points will start talking a little louder and fill in the gap. So it's building a network that's resilient and is functioning at almost maximum capacity all the time. So let's hop on to the next slide.
So again, as we're looking to deploy with our customers and our partners, we're looking to make sure that you've got what is going to take you forward, that this investment is going to move you into the next couple of years, that it's not a consistent reinvestment. And that is both a hardware and a software strategy, as MJ was mentioning. A lot of what we're discussing here is not necessarily that piece of hardware hanging in the ceiling, or even the controller itself. If you're using one in the cloud or locally or wherever the deployment may mandate, but it's the software that goes along with that.
So a next myth talks about, well, a lot of organizations say, well, I'm deploying new access points, but I'm going to use the switches I've got in my closet. And I completely understand that thought and rationale, because sometimes the budget that you have is constraining your ability to actually upgrade everything. But one of the things you do need to keep aware of is that, putting a Wave 2 access point in the ceiling, or a whole series of them, might actually overtax your physical network. And so what happens is the bottleneck that you had, which was on the Wi-Fi interface between the client and the access point, now moves upstream from the access point to the closet infrastructure. Just looking here, just that note, bottleneck has shifted to the access layer. So I've got the client on the left-hand side, and originally, because of older technology, the client couldn't talk with as much speed and throughput capacity on the older access point. So we replaced that access point. And so now the access point's plugged into an older switch. It might be a gigabit switch. And now my access point is, got a bottleneck between itself and the client and the switch that it's plugged into. Huge issue when you've got a location, when you've got 1,000 people in a room. So K through 12, for example, they're creating these rally points. So when they do these situations, they're actually going through and teaching the students where to go in the building, and they say, actually, they're going to do this as a practice, a rehearsal. And they collect in the gym, or they collect out in a field. And now all of a sudden, everybody's there. They've got the entire school sitting there, 1,000 people, all with their phones, all trying to call whoever. And now you've got 1 or 2 access points sitting there, and you've got 300 or 400 clients on an access point trying to talk at the same time. That bottleneck is definitely sitting between the access point and the switch. And the way you scale that is by having an access point that can do 2.5 gig, for example, plugged into a switch that is also capable of doing 2.5 gig. So you have to sort of consider each of these steps and consider at each level in your deployment as to where you need to be aware of where the situations may occur. And as you replace technology in one part of the network, you might be moving what might have been an existing bottleneck to another part of your network.
So yeah, again, when we're taking a look at that, we're taking a look at the network from a holistic perspective. The airspace that we can't see, and we want to get visibility on the access point, the switching infrastructure. So a lot of times what we see is exactly what MJ mentioned, that we've increased capacity in the airspace and in the access point a lot. 2 things happen. One, so a lot of times we're limited to a 1 gig uplink, but we have the capacity to push more than 1 gig of data through that access point. The other thing we see happening is power, where these new antennas, multiple antennas in a box, are drawing more power than the switch can deliver, either on a per port basis or, again, on an aggregate basis across the switch. So it's important to have that traditional wired infrastructure, because we got to backhaul that somewhere. We got to get that working. So again, we work with you to make sure that your investment in your access layer from a switching perspective is able to deliver both the uplink speed in multi-gig and power that you need to drive the bandwidth and drive the PoE.
So I'm sure everybody on the call has discovered that as you sort of open up your network to allow more people to get on your network, you've then have these concerns about, well, who is on my network and under what conditions? Do I understand who they are? Do I know who they are? Are there some constraints about what their access is like and what they can do and what they can see and where they can go when they get on my network? It's a trivial question, shall we say, when you own the asset. So if I've got a computer and I've built an image, I deploy the image on there, and I've got a group policy, maybe it's a Windows machine, it's part of a Active Directory, and I've got a group policy sitting on it, and I know exactly what this machine can do, where it can go, what services are on it, and what is allowed to do. But when I don't own the asset, so a BYOD, for example, then it gets a little tricky. You go into higher ed, universities typically for a while were selling and giving computers to their students, and it was part of the education tuition. Now they don't do that often, and students are walking in with a myriad of different devices and wanting to be able to do anything and go anywhere. So, clearly not knowing what the Wi-Fi password is, if, for example, if there is one, having to log in all the time, generating all sorts of phone calls to the help desk. I can't get on the Wi-Fi network. I don't know what am I supposed to put in here? We've got the whole idea of IoT and Internet of Things. Students are walking in with all kinds of stuff, devices. How do I get them on the network? Get them safely on the network. BYOD breaches. The people come with a device sitting out in the parking lot, and they're getting on my public BYOD network, and they're snooping around and doing things that they shouldn't be doing. So all of these are challenges that you have, and they all need to be addressed. And the final one being malicious users. So you got the guys who accidentally get on the network and accidentally do things. There are others that are intentionally doing what they're doing, and we need to find out who they are, ferret them out, and put policy around their access on that network. We have a product called CloudPath. We'll talk a little bit about it later.
So again, adding security to your networks is a value that IntegraONE brings in a broad-based solution set. So we can take a look at how your security is implemented, what you have involved, but we can also bring in the experts to test that basis out, to provide real-world analysis and real-world penetration testing on your wireless networking to determine whether or not you are implementing adequate security measures, and then the output of that obviously to show you what you are and are not doing, what is and is not working for you, and then provide you with a path forward to get into a better security practice and a better security focus, if needed as necessary.
So new technology brings improved access points. Now there is an FCC regulation. It says an access point can't be greater than 28 dBm, 100 milliwatts approximately. So you aren't allowed to talk really loud, too loud. So we indoor. There are different rules for outdoor access points because the distances are different. But there are definitely rules about how access points are engineered physically to radiate their power. So one of the things that we do is that in all our access points, to improve the coverage that we have. So since there is a rule about how loud the access point can work, we have this thing called polar diversity. So back in the old days when we had 802.11g networks, you have a little rubber ducky antenna and you kind of stick the thing up and there'd be two of them and you'd put one vertical and you make the other one horizontal so you could catch every device, because the device itself, the client device, has got an antenna that's usually along a long edge of it. So if it's a PC or a phone, it depends on how you orientate the screen. With a phone or an iPad, if you hold it vertical to talk to somebody, and if you hold it horizontal to watch a video, you've just switched the orientation of that antenna and how it receives and sends signal. So all of our access points have polar diversity. So they transmit and receive both on vertical and horizontally and in between. And so looking at that slide, it says there's a 3 to 5 dB loss. So an eighth of the power, just taking the device and rotating it 90 degrees reduces your effectiveness by an eighth. So having an access point that actually talks both ways is a huge benefit, because there are FCC rules about how loud an access point can talk. So I've got to make it work efficiently, more efficiently with the capacity that I'm allowed to use. Another slide here. So just another iteration. So 802.11ac, because I've got this polar diversity maximum resource combining, which is all built into what we call BeamFlex. I'm listening on several antennas inside the access point. If you crack open one of our access points, there are actually 4 different antenna arrays inside the access point. And we are able to listen on all of them at different proportions to figure out what is the best combination of those different antennas to get the best performance for that particular client. And this is a selection that's made per client, per transmission.
So again, IntegraONE bringing to the table, the ability to understand this technology, explain and demonstrate its effectiveness within your environment, and tailor and tune that deployment for you as you roll out or as you do your design to see, hey, maybe the Ruckus product solution set does increase your ability to provide stable, scalable, and performing wireless network within your campus infrastructure.
So we were talking a few minutes ago about onboarding devices and the kinds of phone calls that come into help desks related to what activities. And most of them, more than half of them in the analysis we've done, are related to getting a device on the network. It is the most challenging thing, probably often the most frustrating thing. And so, here are 3 steps to improve that process using certificates, trying to make a simple service, self-service onboarding process, and then providing pre-boarding links. So, for example, college students say they're coming to university in the fall. The university can send them an email. And in that email is an embedded link. It says, go click on this link and onboard your devices before you even get here. This is a feature that we have in CloudPath. CloudPath is an enterprise onboarding utility. So it's actually a public certificate PKI infrastructure in a box. And it allows a student, for example, who received a link to go in and onboard their device. So when they walk on campus, their device already has a certificate on it. And as soon as it sees the network that it's bound to, it jumps on that network. And from that point onwards, they're on that campus's network until that certificate expires. And that expiry date is based on the rules that you created around that certificate generation. So CloudPath, just at a glance, it provides automatic onboarding. It is a certificate infrastructure, so that's the gold standard. So it's using TLS. Plain old web browsers use TTLS, so there's only a certificate on one end. You only validate the hosting service, the web server. TLS actually uses certificates on both sides. So I know who the device is because I gave it a certificate, and the client knows who I am because it got the certificate from me, being your infrastructure. It's using standard radius because Wi-Fi just uses standard radius. So there's nothing really strange, nothing crazy you have to do. The tool also gives you device visibility, so you know what devices they are. It does fingerprinting, so it knows it's an iOS device. It knows it's Android. It knows it's Windows 10. You can build rules about that onboarding process as to what that device should or should not be running, should be doing when it gets on the network, when it presents itself. It's rich policy control. We support broad devices, so iOS, Android, Chromebooks. There's been a shift. Apple's about to hit $1 trillion market cap, richest company in the world. But Chromebooks are catching up, and there's a lot of Chromebooks out there these days, and we support them also. And the fact that because we've eliminated passwords, and the related frustration with getting them the right password, remembering what it is, it just makes the experience on Wi-Fi that much better.
So, IntegraONE, we've been doing the BOI business and the network and mission control business for quite some time, and it's important to have that within your wireless infrastructure. Just a key point there, if you don't know who you have and you end up with bad actors, it's very difficult to kick the bad actors off your network unless you have something controlling and authorizing who you have besides a pre-shared key or even an 802.1x authentication. Sometimes we need to kick a specific device off and a specific device with a specific user. So we want to be able to identify that as close as possible just to keep the bad actors out and also keep the good actors in the right area of the network and at the right quality of service.
I love talking about this slide because all of us as vendors, we're all buying silicon from Broadcom, from these vendors who are actually creating the chipsets, and we're plugging them into, and most are plugging them into antennas, and they put a housing around it and some electronics, and they stick it out there. And so everybody says, well, it's commodity. On all access points the same. We kind of say the same thing about Ethernet switching, and there are some differentiating elements in Ethernet switching, but definitely on the access point side. So what we've done, if you crack open one of our access points, so we've got on the left-hand side there off-shelf silicon. We bought it from Broadcom. Everybody does the same thing, and we've got that plugged into in the middle of the slide our really sophisticated antenna system. It's part of BeamFlex, and there's this software control algorithms. We have over 100 patents related to this, and what it does, it allows our access points to be that much more efficient. So if you were to sit and think about I'm a lighthouse, and I've got this light, and the light is rotating around, and it's a sharp beam, and it spins 360 degrees. So instead of an incandescent bulb, which is what most access points would be, we're more like a lighthouse. So we can actually shoot around and find to the client and send a directed signal to that client using a virtual combination of antennas. So there are 4 different antennas inside our access points that are talking about horizontally and vertically polarized orientations. So it's just a closer picture. It's a pretty funky thing. There's one that sort of looks like a taco. There's another that looks like a palm tree. And these antennas, for example, there's one model of antenna we have that has over 3,000 different antenna patterns. And these are selected on the fly. You don't have to do anything about it. We just figure out which one to use based on the telemetry we get back from the client. If we're seeing a lot of discards, a lot of retransmits, a lot of error rates, we say, well, this antenna pattern is not working. We use a different one. And so we're able to actually be that more efficient talking to a client, and they also generate that much less interference because our signal is not going behind us. It's the client sitting in front of us, maybe east of the access point, and we're not interfering with clients that are sitting, west and north and south. So this is sort of a theoretical picture, and if you look at it, there are lobes. These are polar patterns, and based on the antenna combinations, the predominant signal, is in a particular direction, in the direction of where the client's sitting. And so this is just giving you an idea of an adaptive antenna system. So our access points are definitely not, off-the-shelf APs. We are using off-the-shelf merchant silicon that are generated by the manufacturers, but we actually plug it into a very sophisticated antenna system. And all of this we call BeamFlex.
So what that boils down to is, like MJ said, not all access points are created, deployed, and maintained equally in an environment. And what we want to do is come in there and into your environment with you and take a look at and prescribe what is the best hardware and deployment of that hardware to meet your use case scenario.
So we have 2 more slides. And so the second to last is talking about in-building cellular coverage. Huge challenge in some places. I've been to some places where there's just no cell coverage. You walk in, it's like a black hole. There's nothing there, and it's a very expensive proposition to try and solve. You'd have to go talk to a cellular carrier, and they'd have to come in and put a distributed antenna system, perhaps, or a pico site or a micro site. And the interesting thing about it, you'd have to negotiate the same thing with every single one. So AT&T, Verizon, T-Mobile, whoever. And you'd end up with 3 or 4 of them, or you have to pick one. You say, okay, we're serving our students, and most of them are Verizon customers, so we're just going to go to talk to Verizon. So lately, the FCC just opened up, over the last 2 years, actually, they've been working on it, opening up a range of spectrum in the 3.5 gigahertz range. It's actually a range of spectrum that's used in Japan all the time. And it's called the Citizens Band, CBRS, Citizens Band Radio Service. And we as a vendor, we've actually come out with the products that we've just now released, and there are 2 of them, and we're actually doing more of them, that allow you to take one of our existing access points, right, today it's 2, and plug in a device that has a CBRS radio antenna on it. It's a 250 milliwatt LTE site. Now, the interesting thing about this is it works with all different carriers. So I don't have to go negotiate a contract with Verizon and another one with AT&T and another one with T-Mobile. They all work together. And then it's backhauled over the wired network. So there's obviously some things you have to consider when you deploy this. Do I have enough capacity going out of my infrastructure? But you're now offering a service, and it could be targeted. So I can then say, well, it's just in the basement. I don't have this. I have this coverage problem on cellular side. So I'll add these auxiliary devices that they're USB based. So you've got an existing access point sitting there. You mount this device next to it. You plug the existing access point into it, and it draws power. The access point draws power. It draws its Ethernet, and it also offers Wi-Fi and a CBRS system, Citizens Band Radio LTE system. So that's something we're doing. So we're sort of waiting for the client devices to catch up. So iPhone 8 do today, iPhone X's do it today. There is actually one Samsung device that does it. It's a tablet device. So this will be much more prevalent when the carriers can't catch up. The phone manufacturers catch up with CBRS. But it's something to be thinking about, and you've actually future-proofed your network to support this kind of service with our access point technology. This is just a couple of, this is how it would work. So there's the actual Ruckus LTE access points sitting. We've actually got dedicated ones and others that plug into existing APs. There's obviously a switch in the middle because you've got infrastructure sitting there, and then out in the internet somewhere you've got these services. There's three different ones, and there's a virtual a packet core. There's a software service that's actually allocating spectrum, and then there's management. And so all of those are important pieces and components that are part of it, and we provide all three.
Okay. So again, we want to be able to refresh your infrastructure, go through you, and make sure you've got the most comprehensive go-forward strategy. So the last slide. So obviously, more broadband, the more issues you have, the more capacity you're putting in the network, the more broadband you need. You need more bandwidth going out of your network. Right. So we want to help you identify your issues in your wireless networking and allow you to go forward with a strategy that covers as many of them as possible and allows you to continue to grow the utilization and quality of your wireless network. Okay, please remember to fill out our survey that we're going to go ahead and swing around, and then you can collect a nice $10 gift card from us. So don't forget to fill that survey out. Thank you again for joining. And that brings us to the conclusion of our webinar. If there are any questions you have immediately, we can address them. If you want to type them in your chat window, we can address them. If not, have a good day. We'll give a minute or two here if there's any questions coming in. Okay, guys, I don't see any questions coming in. Thank you for your time and listening to our presentation. Have a good week. And as always, if you have wireless concerns, questions, or integrations, please feel free to contact us. Thank you. Have a great day.